Most breaches don't start with some genius hack. They start with a login. An attacker phishes one password, signs in like a regular employee, and from that moment, the network does the rest of the work for them. Because inside a typical company network, everything just trusts you. The file share mounts, internal tools respond. Nobody asks who you are a second time. Earlier this year, a security firm called Zero Networks analyzed 312 enterprise environments, and they found that 80% of internal servers were reachable from anywhere inside the network. Anywhere. So one stolen laptop is basically a master key to the whole building. That's not a bug in one company's setup. That's the default way corporate networks have been built for 30 years. So today, I'm building the model that replaces it. A zero-trust internal API on AWS. The rule is blunt. Nothing gets trusted for being inside the network. Not my servers, not my own machines. Nothing. Every request has to prove its identity with cryptography, or it gets rejected before my code even runs. And I'll prove it works at the end because I'm going to send 2 requests from the same machine on the same network to the same URL. One comes back with the secret data, the other gets stopped with a 403. The only difference between them is identity. Also, every piece of this has a free hands-on lab linked in the description, so you can build the exact same thing yourself. Alright, the build has 2 halves. There's the thing worth protecting, and there's the client that has to prove itself to reach it. Protected side first. The data lives in DynamoDB. I'm creating a table called inventory and putting exactly 1 item in it, a prototype hardware record with a status field that says restricted. That's the target. That's the thing an attacker would want to pull out. And before I've written any API code at all, this data already has its first defense because DynamoDB encrypts everything at rest by default. If someone got their hands on the raw storage underneath, all they'd see is scrambled bytes. And honestly, that's the first zero-trust habit to build. Protect the data itself, not just the road that leads to it. Everything else in this video is layers on top of that. Now something has to read the table, and that's a Lambda function. Small piece of Python scans the inventory, returns what it finds. But the interesting part isn't the code, it's the permissions. The IAM role attached to this function is read-only on DynamoDB. It can fetch items, it cannot write, it cannot update, it cannot delete. Not because I told the code to behave, but because AWS will physically block those calls at the permission level. So picture the worst case. An attacker finds a bug in my function and hijacks it completely. What can they do with it? They can read 1 table, that's the entire blast radius. This is least privilege, and it's the part people skip because giving full access is faster. Then a breach happens, and that shortcut becomes the headline. The Lambda needs a front door, so I'm putting a PI gateway in front of it. A REST API with a single route, a GET request for the inventory. And here's the switch this whole video is about. On that method, there's an authorization setting, and by default it says none. I'm changing it to AWS IAM. That one dropdown changes everything. From now on, every request that hits this endpoint has to carry a cryptographic signature generated from real AWS credentials. The gateway checks that signature math before anything else happens. No valid signature, it returns a 403, and my Lambda never even wakes up. I don't pay for the invocation. The code never sees the request. Anonymous traffic doesn't get to talk to my backend at all. And notice what I didn't create here. No API key sitting in a config file. No password. Those are just secrets waiting to leak. A signature is different, and I'll show you why when we get to the client. Okay, that's the protected half. Now the side that has to prove itself. My internal client needs a network to live in, so I'm creating a VPC, public subnet, internet gateway, a route out to the world, standard stuff. But pay attention to what this network means, because this is where Zero Trust flips the old model on its head. In a traditional setup, the network is the security. You're inside the VPC, so your family and everything opens up for you. In this build, the VPC gives me isolation and control over traffic. That's it. That's all it's for. Being inside it earns a machine exactly nothing. A server in this subnet has the same access to my API as a random laptop in a coffee shop, which is to say, none until it proves who it is. Into that subnet goes the client, a small EC2 instance, and here's a detail I really like. I'm launching it with no SSH key pair, none. When I need a shell on this box, I'll use Instance Connect through the AWS console instead. Think about what that removes. There's no private key file on my laptop that could get stolen. There's no password that could get phished. An entire category of attack just doesn't exist for this machine. What the instance does get is the only thing that matters in this architecture, an identity. I'm attaching an IAM role with exactly one permission, invoke this API. That's it. This machine cannot read the DynamoDB table directly. It cannot call the Lambda. It can knock on the front door and prove who it is, and that's the whole job. Time for the payoff. I'm opening a session on the client and running a short Python script. First thing it does is grab credentials, and this part is easy to miss, but it matters. The script has no hard-coded keys in it. EC2 hands out temporary credentials to the instance automatically through its metadata service based on the role I attached. They rotate on their own. Nothing to store, nothing to commit to a repo by accident, nothing to rotate manually after someone leaves the company. The script picks those up and signs my request using Signature version 4, which is the signing protocol AWS uses for every call in the entire platform. The signature covers the request itself, so it can't be reused for some other call, and it expires fast, so even if somebody captured it off the wire, it goes stale almost immediately. The signed GET goes out to the inventory endpoint. Gateway checks the signature, checks that this identity is allowed to invoke, and passes it through. Back comes a 200, and there's my item. One restricted prototype record retrieved. Now the second request. Same script, same machine, same endpoint, but I'm stripping the signature and sending it plain, instant 403 from the gateway. Nothing about the location changed. This machine is sitting inside my own VPC on my own network, and it still got the door slammed in its face. Proof of identity was the entire difference. Watching that happen in your own terminal is when zero trust stops being a buzzword and becomes just, oh, that's how it works. And this pattern isn't academic. Google spent years rebuilding their internal systems this way after they got breached back in 2009, and their version, Beyond Corp, now covers over 100,000 employees who access internal tools with no traditional VPN trust at all. The numbers back it up too. IBM's breach cost research puts the average breach at around $4.4 million, and organizations running zero trust save roughly $1.76 million per incident compared to ones that don't. The reason is simple. Attackers usually sit inside networks for months before anyone notices, moving sideways from machine to machine. Zero trust breaks that movement. Every hop hits another locked door asking for proof, so one stolen credential stays one stolen credential instead of turning into the whole company. Step back and look at what's actually running here. It's only about 6 pieces. A table holding the secret encrypted at rest, a Lambda that reads it through a role that can look but never touch, a gateway demanding a signed identity on every single call, a VPC that provides isolation but hands out zero trust, and a client that reaches the data not because of where it sits, but because of what it can prove. Nobody in this chain got trusted for free. And every piece is a managed AWS service, so there's no security appliance to buy and no agent to install. It's mostly just IAM configuration, which means the main cost of zero trust here was thinking clearly, not spending money. If you want this to really stick, build it. I've broken the whole thing into 6 short free labs, one each for VPC, DynamoDB, IAM, Lambda, API Gateway, and EC2, and then a capstone that walks the full build end to end. Stand up the network, plant the secret, lock the gateway, launch the client, sign the request, and watch your own 403 turn into a 200 because you attached the right identity. All the links are in the description. That's the video. A lockdown API that opened with no password and no API key, nothing but a proven identity. And that's the direction real companies are heading right now. If you want more real AWS builds like this, subscribe. And if there's an architecture you want broken down next, tell me in the comments. See you in the next one.